So pressing, as I've been discussing, is the process used to separate the liquid portion of the must from the solid portion of the must, skins, seeds, and pulp. The juice drainage is the most common problem with the technology. There are pressing aids that help, so you can throw things in that aren't going to hurt the wine quality, like rice hulls. The rice hulls help add a cushion effect. So as I'm squeezing or pressing down on those solids in the must, the skins, seeds, and pulp, I'm not going to break the seeds. So you can mix rice hulls or stems or certain kinds of plastic pressing aids to help squeeze with the most efficient pressure to get the most juice out and still not break seeds. But the harder you press, the more juice you get out, the more seeds you break. The maximum pressure you want to apply in a press is about 2 bars. I'm not going to talk about what that is, but that's a measure of how much pressure. Pressing is a very oxidative process, meaning you get a lot of oxygen exposure to the wine during that pressing, and you can throw in CO2 pellets, dry ice, basically, and they release a gas that hangs out, hovers, and displaces the oxygen, reducing the oxygen pickup during the press steps. For whites, you can use SO2. It's calculated based on the total extraction of juice and added to the press pan as you're pressing. So the SO2 is acting like a sponge for the oxygen. What else? Pressing may increase the Brix level in red grapes. Pressing reduces a lot of lees. What the heck is lees? Lees refers to deposits of dead yeast or residual yeast and other particles that precipitate to the bottom of a vat of wine after fermentation and aging. So it's that microscopic residue that accumulates. If you look at it, it's all these microscopic particles of solids. We call that the lees. Dead yeast that have died from too much alcohol. They've been partying too long in the tank, and their days are up. And so when you're pressing, you not only are squeezing out all of these dead yeast, but other little microscopic solids that are coming out. And so you can filter that out. I mentioned filtration in another presentation, or centrifugation, where you take the liquid through a device that spins it really fast. The solids tend to move to the outside, and you can separate the solids from the liquid through centrifugation. It's a relatively easy process and fast and inexpensive to filter and centrifuge if you have the right equipment for the task. But it is another step, and there's some time and money spent on this removal of the lees. Here are some common presses: a membrane or bladder press. You can use the term bladder press. And so there's like an inflatable thick-skinned balloon inside of here. And so the must is put into the membrane press, the membrane inflated, and as it inflates, it gently presses on the must, and the juice leaks out underneath and is collected in some pump into a tank. Same exact kind of an idea in terms of the collection, but how you apply pressure is very different. In a basket press, you're literally taking a plunger and you're like pushing down. It's almost like I took a circular piece of wood, set it on top of the must, and I push it down with my hands, and I'm squishing the seeds, skins, and pulp, and out through the slats in the basket, the juice is squeezing out. And underneath the basket, there's a little tray, and that tray collects the juice as it oozes out of the basket. It collects, runs down, and goes into a collection bucket or goes to a pump where it's sent into a different container. So again, the two major common types of presses. The old-fashioned one we call feet. Other types of presses, membrane bladder press, are in the same general category. There are screw presses, moving head presses. Not even sure how a moving head press operates. A screw press is pretty clear how it works. It's using pressure generated by a screw pump device. So as it's going through here, the juice comes out and the skins and seeds emerge afterwards. So now you have skins and seeds with very, very little residual juice, and the bulk of the juice coming out here. So again, it's just different ways of achieving the same end goal. And again, you can add pressing aids, little plastic bead kinds of things, or rice hulls, and then put it into any of these devices if you choose, or you could just do the straight must into these devices. The most gentle are the bladder or membrane style presses. And technically, bladder and membrane are slightly different designs. My understanding is that all bladder presses are membrane presses, but not all membrane presses are bladder presses. But don't write that down. Don't hold me to it. I'm not an expert in the engineering of all of these different press styles. Here's an operator running a must dump device into a press device. Here you can see some juice coming out into the collection tray of another type of press. And what do we do after pressing? Next, we have settling and juice clarification. You can see the unsettled on the left and the settled on the right. This is a white wine making process. This is the stuff I want to settle out. This is the solids, the non-soluble material that I want to get rid of. And so I settle the wine. You can see here on the left-hand photograph, I hope it shows up clearly on your end when you're watching this, but look at the frost on this container. This is really cool. There are refrigeration tubes on a double-walled fermentation and settling tanks, because you ferment and settle white wines under refrigeration. And this refrigeration is being run between the walls of this double wall tank, and it gets really cold. And so you get frost formation, and you can see where the refrigeration devices are and where they're not because of the frost. And so we're doing this cold stabilization settling process to try to stabilize a white wine, get rid of any of those precipitated materials, so we get a nice, clear, clean, brightly colored product. Other clarification methods, here's a drum filter, a centrifuge, a Lees filter, which is a stack of these filter plates, and the wine is literally pressed through the Lees filter under pressure. It's all the same kind of things with slightly different pros and cons. You're just using basic physics of either spinning or filtering to get those solids separated from the liquids. And yeah, okay, I thought I was almost done. I was going to see if I needed a break, but I don't. One last slide, pre-fermentation analysis. So I've got my grapes or my must. What am I going to do with my grapes or must? I need to analyze it. I need to look at what's my sugar concentration. So I look at degrees Brix with a refractometer. I also look at a hydrometer. What's my initial density of my juice? I'm going to check the pH and titratable acidity. And some things we haven't talked about, like the AAN, the amino acid nitrogen levels. I'm going to look at my YAN, my yeast assimilable nitrogen level, which includes the NH3 and AAN minus a measure of nitrogen. So again, let the lab worry about, but yeast assimilable nitrogen is important. This is telling you how much nitrogen is there to feed the yeast as they're eating the sugar. Just like when you're growing plants, what do plants need? They need carbon dioxide from the air. They need nitrogen, phosphate, and potash, nitrogen, phosphorus, and potassium. They need calcium, magnesium, and sulfur. They need all of these things. And some of the things we don't have to worry about, and some we do. In feeding yeast inside of a vat of grape juice, I need to worry about how much nitrogen is available for those yeasty beasties to eat. Will they have enough to complete the fermentation? And there's different species of yeast and different varieties within the species. And there's natural yeast occurring in the environment where the grapes are grown. And then there's yeast we add as a winemaker. I can add packets of dried yeast, just like you can buy yeast at the grocery store to make bread. You can buy packets of those little yeast packets for bread making. Well, a winemaker can buy packets of yeast to make wine. And it's not just, oh, I need a winemaking yeast. I have lots of choices of yeast. Which yeast is the best one for my Brix? If I've got high Brix, what do I need? I need a yeast that can survive high alcohol. Because if I start with high sugars, that means I'm going to end with high alcohol. That's a given. Now, you can't say exactly where that alcohol is going to be without more information, but high Brix, high sugar means high alcohol at the end. If I get the wrong yeast, the yeast will all die before I'm done converting alcohol or sugars to alcohol. And I'm left with a partially fermented wine. Big problem. Again, these numbers are important to make good decisions. The volatile acidity. The volatile acidity, the acidity that is volatile or easily turning to gas, is something you start to see when you're making vinegar. And vinegar is made by the wrong organisms taking over in your tank. The vast majority of organisms cannot survive a fermentation process. Even yeast kill themselves off by the end of the process. But if you get the wrong bacteria in the wrong concentration and they get a foothold in the process and they grow to too high of a level too quickly, you end up with vinegar. Again, it's not a toxic thing. It's not like there's a food safety issue. All the pathogenic bacteria aren't going to survive. I don't know of any pathogenic bacteria or fungi that can survive the winemaking fermentation process. But you can get some of the relatively harmless or completely harmless bacteria that turn sugar into acid. And that's the manufacturing process of vinegar. And a $12 to $20 bottle of wine could turn into a $1 bottle of vinegar. And since you're not trying to make vinegar from the point, is probably a $0 bottle of vinegar. You weren't intending to make vinegar, so what you end up with is actually garbage, not even good vinegar. So that's really, really important. And you not only look at volatile acidity in pre-fermentation, you're looking at it through the fermentation process. You're keeping a close eye on this, as well as these other things. The title of this slide says pre-fermentation analysis, but it doesn't stop at pre-fermentation. You're looking at these things throughout fermentation. How are they moving? How are they progressing? How are they changing as fermentation progresses? Then we get to the malic acid. You certainly can add malic acid as an addition. And there are strict rules. What can you add to a food or to a wine or to many things? Can I add a malic acid to my wine during the manufacture? Yes. There's some things you can add, some things you can't. Microbiological analysis, you're looking at risk assessment for microbial spoilage. You're literally taking a sample of the juice, putting it on plates and trying to grow it up and seeing if you can get any bad bacteria to grow. And it's giving you an early warning sign that might help you, along with the volatile acidity numbers, to see if you might have a tank that's starting to head the wrong way. And depending on what you see, you might be able to do something about it if you catch it early enough. Anyway, that is the end of this presentation.